All right, looking at gas transport. Gases are transported in association with your blood, and there is a direct relationship between your blood system and your lungs. Obviously, getting oxygen in my lungs is not going to help my body at all if it can't get to my cells. So, direct relationship. This is a huge percent, over 98% of oxygen is carried on your hemoglobin. And we did talk about that a little bit in your blood chapter, just that hemoglobin carries oxygen. Well, 98% of oxygen in your blood is carried by hemoglobin. And that, once it carries oxygen, it's called oxyhemoglobin. The remaining 2%, so very small percent, actually goes into your plasma. But most of it, your hemoglobin. Oxyhemoglobin, so when I have my hemoglobin attached to oxygen, it becomes unstable in areas where the concentration of oxygen is low. So therefore, your hemoglobin is going to give up that oxygen. So hemoglobin is carrying oxygen. It gets to a place where there's not a lot of oxygen, it's going to release that oxygen to that area. More oxygen is released when there's a high amount of carbon dioxide because they're going to replace each other. When blood becomes more acidic, more oxygen is also going to be released, and if you have a high blood temperature. So more oxygen is released if I have too much carbon dioxide, if my blood temperature is high, or if my blood for some reason is acidic. A deficiency of oxygen is called hypoxia. So if I have a tissue, and this could be caused by a cut or a severe injury. You know, if you cut an artery in your arm and the bottom part of your arm is not getting enough oxygen, that's called hypoxia. So anytime your tissues do not get enough oxygen, that's called hypoxia. Here again, similar, you guys can look at this, but I can see diffusion of oxygen because 104, and in here I think my oxygen is 40. Here inside my oxygen is 40, so you can see where the diffusion takes place. It's always going to go from higher to lower. So oxygen's carried, hemoglobin. Carbon dioxide can be also transported in your plasma, a little higher percent, 7%. Carbon dioxide can form a weak bond with the globin part of your hemoglobin, and then it's called carbaminohemoglobin, and that's about 23%. But most carbon dioxide, this is the most common one, is carried in a bicarbonate. So here is your bicarbonate. Actually, that is also part of a bicarbonate. So I have carbon dioxide, I have water, I form a bicarbonate that splits into a hydrogen ion and a bicarbonate ion. So the bicarbonate ion is what diffuses in and out of your bloodstream. And the reaction is aided by carbonic anhydrase that you probably don't need to know. What I do want you to know, let's go to the next slide first, is that your bicarbonate will affect your pH level. So when I have a bicarbonate ion, that's going to affect the pH level in your blood. You might want to add that. It's going to affect the pH level of your blood. So carbon dioxide enters your blood through diffusion from tissues. Carbon dioxide is released easily where there's low CO2 pressure, so your lungs, that's where carbon dioxide is released. Here, what happens then is here's my bicarbonate ion. I'm going back the other direction, and when you breathe out of your lungs, you produce CO2 and water. So in your respiration formula, that's where your water comes from here, and your CO2 comes from there. The carbaminohemoglobin also can release its carbon dioxide, and it will diffuse into the blood. Another picture here, again, it's just going to show diffusion. I can see my different levels. And here I can see what happens. So here I'm looking at a cell. Carbon dioxide. It needs to get rid of carbon dioxide. So this is what can happen. It can dissolve quickly into the plasma. It can combine with the globin part of your hemoglobin. But most of it does this. It goes with water. It forms a bicarbonate. And then it forms a bicarbonate ion. And that's transported through the blood. And then eventually that will go backwards. And it's going to go the opposite direction, and carbon dioxide will be released. And this one shows the opposite part of it. Table shows your oxygen, carbon dioxide, kind of wraps it up. You can look at that later. And that is it with the respiratory system.